one of the big hazards that's present in thunderstorms is tornadoes. And tornadoes are oftentimes, in fact, I'd even say that they are the most intense hazards from thunderstorms. They could be over a mile wide, have wind speeds in excess of 200 miles an hour. They can cause some tremendous damage. Now, most tornadoes are common or occur in the months of April through June. And this is what we call tornado season. And the reason why these particular months are the most favorable is we have winter battling out with summer. We still have plenty of cold air up in the northern part of the country over the Rocky Mountains and up into interior Canada. But in the southern part of the United States, we start getting a bigger influx of warm, moist air. And as I just mentioned a few minutes ago, warm, moist air, good for thunderstorms. And so the conditions are just perfect during April through June. I will say one thing. On this particular module activity, or on this particular investigation, there are actually a few difficult questions when it comes to looking at this one graph. And they want you to look at the gray bars on the graph. But I'll just tell you right now, tornado season is April through June. So at least I hope that'll help as you're looking at that graph, that primarily tornado season is April through June. Now with that said, what makes the difference between a typical thunderstorm type of setup and a tornado setup? Well, in order for you to have tornadoes, you still need to have the same conditions that you had with thunderstorms. But you need a few more things. And those few more things in particular are what is called vertical wind shear. And so think about this. If you were to launch a balloon on the ground, if you were to launch a balloon on the surface of the Earth and it were to float up, as it's floating up, the wind that is pushing it may actually change directions or even change speeds as the balloon is rising. That's what vertical wind shear is. Now, here in the Northern Hemisphere, typically the way that wind shear works is you start at the surface with winds coming from the south. And that usually gives you that warm, moist air. However, as you begin to rise into the atmosphere, you get up to the 700 millibar level, the 500 millibar level, and then the 300 millibar level, the winds start to shift. They start going from south to southwest, to west-southwest, and then to west. And so you have this changing direction with height. But a lot of times you also get changing speed with height. The upper portions of the atmosphere have less friction, and as a result, you get faster winds. When you combine these two things, this creates rotation. So now not only do you have these thunderstorms forming, but you also have rotation occurring in them, and that rotation is then what allows tornadoes to develop. Just a little bit more about wind shear. There are two types of wind shear. The first type of wind shear is what's called directional shear, where as you rise up in the atmosphere, the wind direction changes. The second type of shear is called speed shear. Here, the wind blows in the same direction the whole way up, but it gets faster as you go up. Now, either one of these two situations can still create rotation, but it's usually when we have a combination of them that we end up getting the most intense tornadoes. And so what you're actually going to be doing in this exercise is you're going to be looking at surface conditions and comparing them to upper level conditions to determine, is there wind shear and what kind of wind shear it is. To be honest with you, most of this is stuff that you've already done. So we're just giving it a name now. So it shouldn't be too bad. Now, of course, if it is bad, as always, please reach out to me. I want to talk about a few more things about tornadoes before I let you loose, though. So there's a difference between every different type of tornado. No two tornadoes are created equal. Some tornadoes are capable of ripping shingles off of your roof. Other tornadoes are capable of ripping your entire roof off. And other tornadoes are capable of just destroying your entire house. Well, in order to be able to categorize each of these individual types of tornadoes, a scale was created in the late 1960s called the Fujita scale. And this scale actually reigned as sort of the big scale that everybody used around the world for classifying tornado intensity until 2007. Obviously, between the late 1960s and the late 2000s, technology changed quite a bit, and our understanding of tornadoes changed quite a bit. And so, rather than throwing out the scale and doing something completely new, we only really saw the needs to just tweak it. Basically, we took the football and ran with it. And so we came up with what is called the Enhanced Fujita scale. And the way that the Enhanced Fujita scale works is tornadoes are rated based on the damage they cause. So if you're taking my online class, my online lecture class, I have pictures showing like the different types of EF tornadoes and what they cause, how the damage it causes, but I'll just give you the 30-second flyover here. An EF0 tornado, very little damage. An EF5 tornado, total destruction.